Good morning and welcome to AFD'S Academy. I am Achu Francis Deban. I want to take this time out to thank my viewers, especially my dear students who have been very active, following me one and many a time, watching almost all the videos I made, even if they never liked most of them. They just choose still to be there to patronize me. I thank you all. I thank you so much for your patronage. And for the newcomers who just came in, who subscribed recently, I must also appreciate you. It has not been easy, yes, but at least you've been with us, you've been encouraging me. And for those who will be coming, I must tell you that you are welcome in advance. I look forward to have more of you. It's almost a year in the struggle of keeping the educational system tight, and you guys have been there. How else can I say other than thank you? I thank you for your patronage. I thank you for your kindness, your generosity, your patience. I thank you for your interest in education to boost the system. This channel officially was created or is created in order to cover the gap in our educational system. We know too well that the education in our continent, Africa, tends to be dying at a very fast rate. A lot of the educators tends to be looking for the fast lane to make money, and they no longer pay attention or being concerned about impacting. And if this trend continues, we will realize that as time goes on, the system is going to die, because those who are meant to be the future leaders, the future educators, the future intellectuals will not have the passion for it, because the people who impacted never have that passion, so they wouldn't see anything to copy along the line. So if that trend continues, the system or the nation as a whole will suffer. So the reason, once again, was to create a system in which even those who are not privileged to have good educational system or good background in certain courses, especially chemistry, which I teach, you will be able to log into the system, be you where, let's say Sokoto in Nigeria, or Kano in Nigeria, or Maiduguri in Nigeria. These are places that have been plagued with terrorism and many other stuff. So, but then the educational system there has been foiled, but you can still get the best anywhere you are. And I must encourage us, it has not been easy. Knowledge is not free. Knowledge costs a lot. It's ignorance that is free. In order for you to be knowledgeable, they say it's power, of course, remember that? So you must spend some time. You must be creative. You must have the zeal, the passion. That is where you get it right. So, all things being equal, I must say, I thank you. I thank you guys very much for your patronage. I thank you for finding the channel viable or sustainable to a certain degree that you could even subscribe. I thank you. All things being equal, we're going to continue from where we stopped. We've been, for a long time, dealing with much calculations in chemistry. I've not really had time to go into the other areas, because I think that the calculational aspect of chemistry tends to be a problem to many people. But the channel is just not tied down to chemistry. I also take physics and mathematics, and I could also bring some topics in biology if need be. But all things being equal, all of these things will come into play. I will go into some essential integral topics like alcoholism, the chemistry of alcoholism, where people take alcohol, they do not understand what happens. Many pastors have got many interpretations to all of that. But when we take that, we begin to see the impact, the importance, the negative side effect and all of that, and the chemistry that takes place in the brain. We see the structural framework of all of that. So we begin to appreciate what we do or what people do and all of that. But all things being equal, be it as it may, we'll continue from where we stopped. Today, we're going to take some calculations again in volumetric analysis. I've done a whole lot of calculations across board, but I always find it interesting when I come across new questions that I've not solved before. I will always want to share them. For you students in high school, you see these various calculations in different aspects. Some of you don't know how to solve them. But if I have a broad spectrum of calculational framework, you can easily go to the channel, you get a whole lot of stuff, you will have that idea. You'll be able to solve those problems which you find difficult. So that has been the interesting part of it. But as time goes on, like I said, we'll go into the practicals aspect to where we will be having live practicals. You see how these things have been done. So let's begin from somewhere. The calculations are still based on volumetric analysis, which is acid-base titration calculations. So, I always do, I will read the question, I will capture all the given variables, then we will solve that which is required. So, let me read the question before we begin. All right, it says A is a solution of an acid with formula H2X containing 2.45 gram in 500 cm cube of solution. B contains 3.90 gram of sodium hydroxide in 1 dm cube of solution. If 25 cm cube of A is completely neutralized by 24 cm cube of B, we should calculate the mass concentration of A in GDM cube, the molar concentration of B in mole per dm cube, the molar concentration of A in moles per dm cube, and the molar mass of H2X. We can even add something, the value of X, so that we know what X is, so that we'll be able to establish what the formula will be. So this is the question. Let's list them out, which is the given. All right. We say A is H2X. This is A, H2X. And B is sodium hydroxide. Ca, Va, Na. Cb, Vb, Nb. Okay, we say that A is this containing 2.45 gram in 500. Contains 2.45 gram in 500 cm cube. Okay, B contains 3.90 gram of sodium hydroxide in 1 dm cube. So this is direct, which is the GDM cube of B is 3.90 GDM cube. Alright, if 25 of B, the volume of the base is 25 cm cube. If 25 of B gives us 24, if 25 cm cube of A, the volume of the acid is 25, give us 24 of B. If 25 cm cube of A is completely neutralized by 24 cm cube of B, we should calculate the following mass concentration of A. So first question first. 1 mass con of A is the first thing we should look for. Now, if you check my previous videos, you realize that I've given us a lot of formulas in terms of volumetric analysis. And if you follow those formulas very well, you remember how to go about things like this. Most of the questions are not very direct. And in mass concentration, we say the formula is molar con over relative molecular mass, which is one of them. And we also have mass over volume in TNK, which is another formula. So if you check molar con over relative molecular mass, it's not applicable in this sense because the if you look at the molar concentrations, they are empty, so it's not applicable here. But we have another one which is mass over volume. By the formula, we have 2.25 grams in 500 cm. This is the mass and this is the volume. In that sense, we can use this to get the mass concentration of A. So it's direct. For the B, they've given us already. So let's see from here. So this is mass in gram over volume in dm3. And the mass is given to be 2.45 gram. 2.45 gram. The volume is given to be 500. Remember, it's in dm cube, which means we have to convert. Yes, it's dm cube and it's given to us in cm cube. So we have to convert the cm cube to dm cube by dividing by 1000. So I will now have over 1000 dm cube. And this is equals to 2.45 gram over 0.5 dm cube. And this is finally what? So we're going to check. First of all, 500 divided by 1000 is 0.5, which we've known. Divide this, you get that. So now 2.45 gram, which is 2.45 divided by 0.5, will give me 4.9. So the mass concentration is 4.9 GDMP. So we've solved our first question from the given. So I have my mass concentration now. Permit me, if I have to take this out, because this is no longer needed, I can now put that the GDMQ of A is equals to 4.9 GDMP. The GDMP, what I meant is the mass concentration. So let's take what is next in the question. The next one is molar count of B in mole per DMP. Molar concentration of B. Now, if you look here very well, you realize that what we've got here is for A, and this is for B. Now, how can we get our molar concentration? They're asking us of the molar count of B. We have a method, different formulas, so let's look at the formulas together. We have molar count, which is also known as CAVA over CBVB is a formula which we can use to get the molar concentration. So by virtue of that, that one is out. And we also have molar count equals to amount over volume. Amount is not given, even if there is volume. So that formula is also out. Another one is molar count equals to mass concentration over relative molecular mass. Now, the mass concentration is given. The relative molecular mass of sodium hydroxide is 40 if we calculate that. So you realize that that is the only formula that is viable in that sense to get the molar concentration of what? B. So let's proceed to do that now. So the knowledge of all the formulas is integral in this sense, because if you do not remember all the formulas, you cannot apply them. So the first thing first is for you to be able to memorize all the formulas and have them handy. So when you come across questions like this, you'll be able to deal with them. So let's see. I'll take this out since we're done with this so that we can calculate the molar concentration of the B. Alright. Molar count of B is equals to mass count of B relative molecular mass of B. Now the mass count of B is 3.90 GDMQ. The relative molecular mass of B is 40 gmol. Now, let us see how do we get this 40. So I have NaOH. Sodium, the mass number here is 23 plus oxygen is 16 plus hydrogen is 1. So if you add all of these, 24 plus it will give you 40 gmol. So I can take that out now so that I can proceed. Now 3.90 divided by 40 is 0.0975. I now have 0.0975 mole per DMP. Now I come back here, I have 0.0975 mole per DMP. Okay, that's second. The third question says molar count of A in moles per DMP. Now we've got to the molar concentration of the base. Now we are asked to get the molar concentration of the acid. Questions such as, why can we use the same formula, which is mass count of B over relative molecular mass of B? If we apply it to A, because we have mass count here, can we use mass count of A over relative molecular mass of A to get this? No, we can't. Why? It's because the relative molecular mass of A has an unknown in it, which is X. We don't know what X is. So by virtue of that, this same formula which works for B cannot work for A. So we have to look for other formulas. Remember, we also have molar count is amount over volume. There is no amount here, there is volume. So that formula still will not work. So you begin to see that what works for B is not working for A. So we look for more formulas, which then can we use to sort out. Then we have the formula which is the CAVA over CBVB and so on and so forth. So by virtue of that, we have we have our CB and we have our CA, which is unknown. If we make CA the subject, we'll be able to get the concentration of what? The acid. But before that is done, we must have to balance this equation to know what is the number of moles of the acid and the number of moles of the base. So let me balance the equation so I can put in the variables for NA and NB. Then we can use the CAVA formula to solve that. So I'll pick it up. Now, in the balancing of equation, I have H2X plus sodium hydroxide. Alright, we have sodium X plus water. Now let's balance this. We know that this is the metallic side, we'll come to the non-metallic side, and the metallic here will come to the non-metallic, so that is okay. So begin to look into the variables. We have 2 hydrogen here plus 1 here, 3. We have 2 here. So it's not balanced. If I have 2 here, I will now have 2 hydrogen plus 2 hydrogen, 4. And I can easily put 2 here. I have 4 hydrogen. So hydrogen is balanced. Now let's look at oxygen. Oxygen is 2. Oxygen is 2. It's balanced. Let's look at, what again? Sodium is 2. And here sodium is 1. So if I have Na2, I think sodium is now balanced. Now X is 1 and X is 1. So in this sense, my equation is balanced. And the mole ratio is, the base is 2 and the acid is 1. So with this, my equation is balanced. I have gotten my Na and my Nb. Then I can apply the CAD formula, I will get the rest of it. So permit me if I have to take this out so that I can break in that formula and let's see what we do. So we have the formula here, CAVA over CBVB is equals to Na over Nb. Alright? I'm looking for Ca. So if I have Ca would be, by cross multiplication, I have CBVB Na over Va Nb. So I move on. What is Cb? Constitution of the base is 0.0975 mole per dm³ times volume of the base is 24 times number of moles of acid Na is 1 all over volume of the acid is 25 times number of moles of the base Nb is 2. So if I move on, I will have 0.0975 times 24 divided by 50. 0.0468. 0.0468 mole per dm³. 0.0468 mole per dm³. Now let's see what is next. Okay. Okay, let's move on. The next question here says molar count of A in moles per dm³. Molar count of B, we've done that. Now the molar mass of H2X. Now, we've gone far, it is important you listen to the question again so that in case you are just joining, you will understand what we're doing. We say A is a solution of an acid with formula H2X containing 2.45 grams in 500 cm³ of solution. B contains 3.90 of sodium hydroxide in 1 dm³. If 25 of A is completely neutralized by 24 of B, we should calculate the mass count of A in moles per dm³. We've done that, we have 4.9. We have the molar count of B in moles per dm³, which we've done that, which is 0.03. And the last one is the molar concentration of A in moles per dm³, which we have used our CAVA formula, and finally we are there. So now let's proceed further to see what we have. Alright, 0. This is what we have. Remember how we did this? We multiply this times 24 divided by this and this. 25 times 2 is 50. If I have to check that again, I will. I have 0.0975 times 24 divided by 50. 0.0468. Alright, let's proceed. I'll take this out so that we can proceed to get the last question. Says the molar mass of H2X. Now, the molar mass of A, molar mass is mass count of A over molar count of A. The mass count of A is 4.9. 4.90 GDM cube over the molar count of A is 0.0468. 0.468 mole per GDM cube. And this is equals to, alright, 4.9 divided by 0.0468 is 104.7. So here I have 104.7 or 105. So this is in G mole. So if that is true, that's what we have now. If this is true, we have to now proceed. That is where the question ends, but let us find out what X is. So I can easily now say, which is like a bonus, H2X is equals to that, which is 104.7. Now, this is 2 times 1, which is 2, plus X is equals to 104.7. So X is equal to 104.7 minus 2. Minus 2 gives me 103 total. 103. That's the value of X. So that's our first question, which we solve. We're going to take a couple more to see what we can get. All right. Let's take some more questions on relative molecular mass before we can move further. All right. I have another question here. Find the molar count of 0.53 gram of sodium triazocarbonate 4 in 100 cm³ solution. We say we should find the molar count of 0.53 gram of sodium triazocarbonate 4, 0.53 gram of sodium triazocarbonate 4 in 100 cm³. 100 cm³. All right. Solution. Now this is just a direct question, but short. We should find the molar count. Is that what I said? I'll find the molar count. Okay, now. Molar count is equals to. Now let's look at what is given to us. We have 0.53 grams of this in 100 cm³. What can we do with all of it? Here, we can get mass concentration. Because mass concentration is mass over volume. If we've gotten a mass concentration in this, then molar count is mass count over relative molecular mass, then we can get the relative molecular mass. So it looks very short, but a little complicated. So let's proceed. This is what we're at. But before we use this, we must first of all get our mass count. First, mass count is mass over volume. Yeah, volume. The mass is 0.53 gram over volume in GNQ, which is over 1,000. And my 100 divided by 1,000 is 0.1. So I have 0.53 gram over 0.1 GNQ. And this is equals to what? I have 0.53 divided by 0.1. This is 5.3. So I have 5.3 GDNQ. So this is the mass count which I've gotten. And the relative molecular mass of this is what? Let's calculate that. Na2CO3. Sodium is 23 times 2, plus carbon is 12, plus oxygen is 16 times 3. Okay, this is 46 plus 12 plus 48. 40 is 80. 90 is 100. 106. So this is 106 G mole. Now if I put these two variables here, molar count is mass count over relative molecular mass. Mass count is 5.3 GDNQ over relative molecular mass of 106 G mole. And this is equals to 5.3 divided by 106, 0.05. The molar count is 0.05 mole per dm3. Okay, this is the final answer. Molar count is just this. All of these other ones is for us to get what we're looking for, and that is how everything goes. Let's take some more questions. All right, 0.05. Okay, we've done that. Okay. A is a solution of HCl. B is a solution containing 7.90 grams of K2CO3, potassium carbonate 4 per dm3. Put the acid solution A into a burette and titrate or 20 cm³ portions of the base. Using methyl orange as the indicator, record the volume of your pipette, tabulate your burette readings, and calculate the average volume of acid required to neutralize the volume of base. From your results, calculate the molar concentration of A, the mass concentration of A. I think this is a direct question. A equation of reaction is given here. I don't know. Okay, let's just solve it. It's direct. I do not see the complexity. I would have loved to skip it, but let's just solve it for the sake of solving. A is HCl, B is K2CO3. Now A is a solution of HCl, B is a solution containing 7.90 grams of K2CO3 per dm3. So they're giving us the GDMQ from the beginning, which is 7.90 GDMQ. That is the mass concentration of the base. This has been given directly. We should put A into this, okay? Put the acid solution A into a burette and titrate with 20 cm portions of the base, using methyl orange as the indicator. So the volume of the base is given to be 20 cm3 and not 25. Okay, using methyl orange as indicator, record the volume of your pipette, tabulate the burette readings, and calculate the average volume of acid required, the average volume of air to neutralize the volume of base. From your result, we should calculate the molar count of A, the mass count of A. The equation of the reaction is given to be this. Let's take the equation: 2HCl plus K2CO3, which gives us 2KCl plus CO2 plus H2O. So if they've given us equation of reaction, so the number of moles of base, NB, is 1, while the number of moles of acid is 2 from the equation of reaction. So let's say, suppose the volume of the acid is 22.60 cm3, VA. Suppose the volume here is 22.60, what is it? cm3. Suppose the volume of the acid is 22.60 cm3. We should calculate the molar count of A first. So now let's look at it. This is all that has been given. I'm going to reclaim the equation of reaction which was also given. So we can find out, we should calculate the molar count of A. Let me take this out. Now, for us to get the molar concentration of the acid, what do we do? They did not give us the molar count of the base, so we cannot use CAVA. See how tricky it tends. I thought it wasn't, but it's a little tricky, but then we can still use our knowledge of the formulas to sort it out. Now, since CA wasn't given, and they're asking us for the concentration of the acid, before we do that, we must know what the concentration of the base is, so we can apply the CAVA formula. So this is all we need, the mass concentration of the base, so that we'll be able to determine the molar count of the base. Then we'll use the CAVA to finalize. So by virtue of that now, what are we going to do? We have to first of all calculate the molar concentration of the base, although it wasn't asked, but that is what we must do first in order to proceed further or to move successfully. So now, let's see. Molar count of B is equals to mass count of B over relative molecular mass of B. And this, the mass count of B is given to be 7.90 GDM³ over relative molecular mass. We have to calculate this. Potassium is 39 times 2 plus carbon is 12, plus oxygen is 16 times 3. So if I have 39 times 2 is 78, plus 12 for carbon, okay, is 90 plus 48 is 138. So the relative molecular mass is 138 gmol. So 7.9 divided by 138 will give me the molar concentration. 7.90 divided by 138 is 0.0572. 0.0572 mole per dm cube. So I come back here, I have CD is 0.0572 mole per dm cube. Alright, now we've gotten that, we have to now use this to calculate the concentration of the acid. So I can now, then we have to take this out so that I can use a CAVA formula to get this concentration of the acid. So let's see how that works. Okay, now using the formula, I want to get the concentration of the acid as required. So I will use the formula CAVA over CBVB is equals to NA over NB. Now, CA is equals to CBVBNA over VANB, and this is equals to CB, concentration of the base is going to be 0.0572 mole per dm cube times volume of the base is 20 cm cube times number of moles of acid is 2. This is all over. Volume of the acid is 22.6 cm cube times number of moles of the base is 1. So this all is equals to what? So I have 0.0572 times 20 times 2 divided by 22.6, and that is 0.101. So this is 0.101 mole per dm cube. So I have CA will be 0.101 mole per dm cube. Okay, now what is the next question? Where is it? 2. The mass count of A. Now from here, we can easily get the mass concentration. What is mass concentration? Is molar count times relative molecular mass. So we just multiply this and the relative molecular mass. So let me take this out so I can sort that out. Lastly here, we have mass count of A is equals to molar count of A times relative molecular mass of A. And the mass count of molar count of A is 0.101 mole per dm cube. Times 36.5 gmol. Now, how do I get 36.5? The mass number of chlorine is 35.5 plus 1, so 36.5 gmol. So if I have to multiply that, 0.101 times 36.5 will give me 3.69. So this is 3.69 GDN cube. So that is it. We're going to take another question. Okay. Next question says, let me check something. Purity. Percentage purity. Okay, let's take something on purity. Just one. Then we'll take one on maybe water crystallization or stuff. So let's just do 2 questions here. say A is a solution containing 3.60 GDM cube of impure H2SO4. So we have A is H2SO4. The GDM cube is impure GDM cube is 3.60. B is a solution containing sodium hydroxide. This is B, sodium hydroxide, containing 2.5 GDM cube. The GDM cube is 2.5 GDM cube. Put A in the burette and titrate it with 20 of B. Volume of the base is 20 cm cube. Using material range as an indicator, tabulate your readings and find the average volume of acid used. Okay, assuming the average total value is 24.8, volume of acid is 24.8 cm cube. Using the equation of reaction, which is usual, Na is 1 and Nb is 2. So you should by now know how to balance your chemical equation so that you wouldn't find it difficult, because in probably exams, the equation of reaction may not be given to you, so you'll be required to balance it yourself. So let's say that, how do we get that? We have H2SO4 plus NaOH, which gives us sodium sulfate plus water. We have 2 hydrogen, 2 plus 1, 3. If I have 2 here, I have 4. I have 2 here. So, and I will also have 2 here. So that's why we have 2 for base, 1 for acid. So let's move quickly. Okay, we've gotten that. We should calculate concentration of A in mole per dm cube. Now, we want to get the concentration of the acid in mole per dm cube. If this is everything, we have no molar concentration of the acid given, and that's what we want to calculate right now. And they give us the mass concentration of impure, so we can use this to, the formula is supposed to be, how do I call it? Molar count is equals to mass count over relative molecular mass. The mass count here is impure, so we can't use that. So for us to be able to be successful, we have to first of all calculate the molar concentration of the base, Ca. Then we use CAVA to get this. So when we use CAVA to get this, then from here we can get the mass count of pure, because this is that of impure. So that's why the question says, first question, concentration of A in mole per dm cube. Let us see. Alright, let's start with, we have to get this first before we can get this. So for here, for the B, molar count of B is equals to mass count over relative molecular mass. Mass count is 2.50 GDM cube over the relative molecular mass is 40 g mole. Remember that? We've done it before. And this is 2.5 divided by 40, 0.0625. 0.0625 mole per dm cube. So now we have our CB to be 0.0625 mole per dm cube. So that is for B. Now we are going to use that to get out of A, which is our only way out. Otherwise we will be stuck. So that's our only way out. So I want to use that to see what we do. So now let's move on. Remember, the molar count of the base wasn't asked, but then here we have it. So let's move on to get the molar count of A, which is given. That of B wasn't asked. So now I want to go further. I can solve that by using my CAVA over CBVB is equals to NA over NB, and CA is equals to CBVBNA over VANB. This is equals to CB is concentration of the base is 0.0625 mole per dm cube times volume of the base is 20 times number of moles of acid is 1 all over volume of acid is 24.8 cm cube times number of moles of base is 2. So all of this I have 0.0625 times 20 divided by 24.8 divided by 2, 0.0252. This is 0.0252 mole per dmq. I'll come back here. CA is 0.0252 mole per dmq. Now that's our first question. Let's see the second question. Concentration of A in GDMQ. So we're going to use that to get the concentration of the mass form of the acid. This is that of impure, so we have to get that of pure. What we are getting now is for pure, so I'm going to take this out. Now, mass form of A is molar count times relative molecular mass. The molar count is 0.0252 mole per dmq times relative molecular mass is 98 G mole. So if you remember again, hydrogen is 1 times 2 plus 32 plus 64 will give us 98. So 0.0252 times 98 is equal to 2.446 or 47. 2.47. Remember, the mass concentration of pure must be lower than that of what? Impure. So that's true. So pure GDMQ is equal to 2.47 GDMQ. Okay, 2.47. Now I will take this out. Let's see what's next. Concentration of GDMQ, percentage impurity of the acid. Lastly, let me take this 2 out. Now, what is the formula for percentage impurity? We say percentage impurity first is equals to the mass count of pure over the mass count of impure times 100. Then percentage impurity is mass count of impure minus mass count of pure over mass count of impure times 100. There's another way too we can go about that. You can begin by solving the percentage purity, which you know. We have another formula which is percentage purity plus percentage impurity is equals to 100. So you make your percentage impurity the subject, which becomes 100 minus percentage purity will give you your answer. But that is a long route. So now we have the mass count of pure and the mass count of impure. So we can just proceed further to see percentage impurity is the mass count of impure minus that of pure over impure times 100. I think that is going to be faster. So here we have percentage impurity of A is equals to mass count of impure is 3.60 minus mass count of pure is 2.47 over mass count of impure, which is 3.6 times 100. And this is equals to what? So I have 3.6 minus 2.47 divided by 3.6 times 100 is 31.4. 31.4% impure. So the impurity is 31.4. So which means purity is higher. Okay, let's move on. We have a lot of other questions. Let's take something simple. Okay. We have questions on water crystallization. Okay, if you ask me, I will say we can stop here for today. At least we've been able to touch questions on relative molecular mass, questions on percentage purity and impurity. That's what it means. But I'll have a couple of them again. In case of necessity, we can bring them forth so that we see what we got. But for the time being, this is what we have. We've done justice to the basic things which are required. In all of these things which we solve today, it is important that you first of all have the formulas offhand. If you do not have the formulas offhand, it is almost impossible for you to go about it, because
some questions like you've seen require more than one formula. So if you can't remember all of them, it becomes an issue. So I look forward that I'll bring more calculations to us when we need them, when required, or by your recommendation. We'll bring more of them, and we're going to go a little abroad to bring some mathematics as time goes on, probably from maybe next week. I have some videos on mathematics, statistics, and all of that, and some physics topics. We'll bring them all in, all for our own edification. Knowledge, they say, is power. You need it. So I'll do the best which I can to give you what you deserve. Thank you. It's always my pleasure to have you. Have a nice day.